Well, hello. This is not a normal live stream for Advent of Code. I saw somebody talk about what it would be like to do Advent of Code if it were for production style code. And that made me think, as a unit test person, that made me think, okay, what would it look like if I were to do Advent of Code from a TDD perspective? So a little bit of background on why I think this is interesting, but also why it's not the way I normally do this. Even though when I write production code, I write it all in TDD. The answer, first of all, the easy answer is why don't I normally do this? For speed. Advent of Code has, unless they tell you that there are error conditions to take into account, there are no error conditions to worry about. Unless performance becomes a problem, nobody talks about performance. And, there's really no reason to have the code be as good as possible and as maintainable as possible. You're just trying to get to the answer as quickly as you can. I wouldn't say I'm super competitive. Like my scores are typically like I'm, in the 1 to 2,000th person to finish. So it's not like I'm ever on a leaderboard. So not like I'm super fast at this anyway. But I thought it'd be interesting to take one of the problems and do a TDD style and see where that gets us. I don't think it makes sense to do every day. As I'm recording this, it's December 6th, so we've already done 6 days. So you can see if we bring this up here, I have my 12 stars for 6 days. I've decided that day 4 was kind of an interesting one to see what it would look like if we were to approach this from a TDD perspective. So that's what I'm going to do today. This URL down here at the bottom, is not the correct URL that I normally. That's my normal Advent 2022 URL. If I'm gonna post this code somewhere, I'll put it in a different place. So sorry about that. Actually, let me just take that URL away. Goodbye. There we go. That way we don't have to look at it. All right. So this is going to be day 4 from the perspective of TDD. So again, not for performance, not how fast can I solve this, but if I were given this kind of a problem to solve, obviously the problems generally don't come to you, expressed like this. But if I was given this problem to solve, what might I consider doing it TDD style? Okay. The other thing you'll notice is because I've already finished this, the normal process of submitting my answer and seeing if it's correct is not going to be there. I have a set of data that I've already gotten a correct solution out of this from, but we'll just pretend. Okay. So what does day 4 say? Space needs to be cleared out before the last supplies can be unloaded from the ship, so several elves have been assigned the job of cleaning up sections of the camp. Every section has an ID number, and each elf is assigned a range of section IDs. However, some of the elves compare their section assignments with each other and notice they have assignment overlaps. Try to quickly find overlaps and reduce duplicated effort. The elves pair up and make a big list of section assignments for each pair. So the puzzle input is pairs. So every elf pair has a section, has a range of the area that they're cleaning up. So that's going to be our first set of test data. So let's see. So consider this. For the first few pairs, this means within the first pair of elves, the first elf is assigned 2 to 4, while the second elf assigns 6 to 8, 6, 7, 8. So there's no overlap here, right? We could actually just start with that as our first set. We already have 2 things to do here. One is to parse this into whatever data structure that we're going to have, and then to be able to test this and determine whether we have any overlap. Because they want to find overlaps to remove duplicated effort. Okay. We're going to continue to read the rest of the puzzle because we want to make sure we're solving the right problem. Before we get to the bottom, though, we're going to come back up and start thinking about this from a TDD perspective. I'm just kind of pointing things out as I see them as we go. Okay, so the second pair, the second pair were each assigned 2 sections, 2 to 3, 4 to 5, yep. Elves in the third pair, 5, 6, 7, 7, 8, 9. So that's our first case of overlap. All right. So then they also give you a visual representation of what these are. We will not need the visual representation in our testing, but it is useful for us when we're considering the problem to be able to look at it visually and make sure that we understand why there's overlap. Because the first version of this, they're going to ask us not to solve for overlap. They're going to ask us to solve for containment. All right, so some of the pairs have noticed that one of their assignments fully contains the other. So 2 through 8 fully contains 3 through 7, so that's this one right here, right? And 6 through 6 is fully contained within 4 through 6. Yes, that is true. So how many assigned pairs, in how many assigned pairs does one range fully contain the other? So this is what we're doing, is we're after containment. I just created this project. I'm going to go make sure that we have newest versions of everything here. Let me have a terminal window. We have a terminal, right? Where's terminal? Terminal. There we go. Give me a terminal window. Let's go to. Oh wow, that looks terrible. Let's fix that really quick. I have a customized prompt. So let's go to the terminal. Terminal. Let's make sure we use one of our nerd fonts. I usually use ISFCA nerd font. Let's make it a little bigger as well, so it'll be easier to see. There we go. All right, so let's go to right here, Advent 2022 TDD. That's probably going to be the project name if I upload this to GitHub. So the first thing I'm going to do is I'm going to run .NET Outdated. So I have a tool that can actually tell you whether things are out of date. So for example, cover the collector 3.2, we're actually not going to be doing code coverage, so I'm just going to go ahead and remove that. But if you want to upgrade that, you can do that. And then Microsoft Test SDK 17.4.0. All right, so I save that, rerun .NET Outdated. It should say, hey, everything is good to go. Okay, everything's good to go. We're going to let the terminal go minimized. We might come back to that. Are we happy with the project? Sure. Implicit usings are good. Nullable's good. Packable false is fine. Net 7.0 target framework is totally fine. Okay, project-wise, that looks okay. Let's start then. The next thing we're going to do is we're going to add a folder. We're going to call this day 04 because we're doing day 4 stuff, right? And so we know we need to be able to parse this stuff and come up with ranges, and they're in pairs. So what would the first set of tests be that we want to do? So let's create pair parser tests. All right. We'll do that. You need to be public. And then we're going to need a pair parser. All right, because that's what we're going to test. So we'll go ahead and we'll make pair parser. You can also be public. I don't know why it doesn't give me a blank line there. Maybe somebody from the Visual Studio team can tell me one day. All right, so from a pair parser tests, so we know we have, for example, this as an input. We have all of these as an input. But let's just start with one, right? That's an easy place for us to go. Let's do a test for that. Like can parse pair of ranges. Okay, so the input is going to be this. Whoops, it's going to be this, right? What are we going to want out of this? What are you upset about? Fact. Oh yeah, you want me to be void. That's what everybody's upset about. What is the data structure that we think we want, right? We know we need to find contained ranges. So we need to know essentially, you know, where we are here and where we are here. And so there's a couple of ways we can think about doing this, right? One way we can think about doing this is we can just sort of record the left and right, or lower and upper, whatever you want to call it, right? We could also record every space, right? So this would be, in this case, we'd end up with 2, 4, and 6, 8, right? So we could record every space. So in this case, what we could do is we basically end up with arrays for the 2 people in the pair, right? For the 2 elves in the pair. Those are really kind of, I think, our first choices. So that's our first decision, which is what data form do we want to see this in? Given that we're going to want to do ranges, We want to check containment. Uh, I think we could probably just go with lower and upper. Like, I don't think we need to have this. I mean, if you think about these numbers could be really big. Like, what if this is 400, right? Then this would be 2, 3, 4, 5, 6, 7, 8, 9, all the way out to 400. And that's probably more data than we need, right? Because we're only trying to solve one problem right now, which is the containment problem. So I think we're going to go with left, right. There is a data type, right, called range. So if we were to go look at what does range look like, range allows you to basically store a start and an end as an index. All right. So what is an index? An index is, generally speaking, an int. That seems entirely reasonable. So maybe we'll do this with range. Okay. So then what our test would look like would be we'd want the result to be, let's get our system under test, SUT, system under test. This is a common thing people like to do. And by the way, when you see me putting blank lines in here, we'll talk about this in a second. Range, act, and assert. That's kind of the implication. I'm not going to put those comments there every time, but we'll come back to that in a second. So our system under test is a pair parser. We'll assume we have to do one of these up, right? And then we'll say the system under test has no methods on it, so we're trying to define what is it going to be, right? So we'll just say parse the input, right? And then the result is probably going to be something like we want two ranges, so we could take a range array. We could take a tuple of ranges, right? So what if we did that? So what if we said the form that we want this to be in is a range for the first elf and a range for the second elf. That's the form we want this to come out in. And we'll eventually go back to using var here in a minute. We're just going to let the system help us out a little bit. So I'm going to put the type there so we understand what it is, right? And then what we'll be able to do is we'll be able to write our asserts, which is the first, right, so results dot first dot start is 2, right? And then 4 is the result first end. And then 6 is the result second start. And then 8 is the result second end. So what we're left here with is we are in a red state because if we try and compile, obviously the compile is going to fail because the pair parser doesn't know what parse is, right? So that compile failure you consider to be a red state. So we're now in a red state. Before we had any tests, obviously we were in a green state. But now we're in a red state, which is fine. The other thing I'm going to do is I'm going to open up our test explorer. We're gonna load you over here. All right, that'll be fine. So Advent 2022, day 4, pair parser tests can parse pair of ranges. We obviously haven't run this test and we can't because it won't compile, but for the moment, if we were to not have this test here, right, and then I were to build, what we'd see is that everything here would disappear and say, hey, you don't have any tests. You can consider that to be a green state of sorts. All right, so what we need is parse. So I put the types there because I can have it generate the parse method for us. So if I go ahead and do that, now go to the pair parser, which, let's see if we have enough space to do this side by side. We probably do, right? So I want to parse this input and get back that. So that's fine. Now we should be able to compile again, and we should have our tests, right? And if we run, we should be in a red state because we wrote a failing test. So here we are, we're in a red state. Of course, our red state is we have not implemented exception. That makes sense, right? Actually, let's do this. No, that's fine. So what is the simplest thing that I can do to get this thing to pass? So some of you might be tempted to actually start writing the parser right now, but I like to basically work my way into an implementation based on what the test data tells me I should do. Okay, so the easiest thing for me to do would be to just return a new range with 2 and 4, and a new range with 6 and 8, right? And what are you upset about? Oh yeah, these are, this is not a collection, those are constructor parameters. Duh. Right, so if I compile this and run it, right, we will see that they will run. I think we can set up auto run, right? Let's see. Is that what this is? Is that what this is? Run all tests in view. I thought there was a way for me to do auto run. Live unit testing windows. There's a live unit testing window. Use the playlist editor in the live unit scan. Well, let's see what happens here. We're playing around here. Let's see what happens. Live unit testing. Configure live unit testing, blah, 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 blah. When it builds. Okay, when it runs. Okay, let's do that. We have to, whatever, sure. Okay. Here we go. We'll start the live unit testing. No idea why it's taking so long, but let's go. Click include all tests. Include all tests. I obviously don't use the live unit testing very much. And really don't know what's going on here. It's just taking a while. Okay, so let's actually try this then. Let's see if this is useful for us. Because I think what'll happen here is as I just do this and save, it'll rerun the tests. Okay, perfect. Now I don't even have to run the tests. Okay, so 8 is where we want to be. That puts us back into a green state. So yeah, that's kind of interesting, right? But that's not enough. Obviously, this implementation isn't going to work for the long haul. But if we come back here and we grab another piece of data, right, we should be able to write a very similar test. One of the things that's available in ActionUnit.net, which is a test framework that I write, which is what we're using, is you can have a data-driven test, right? So what if instead of having this be a fact, we call it a theory? What you'll see is we'll get an error here, which is, hey, theory method should have parameters, add parameters to the theory method, right? And so string input. Okay, so now we don't have this as our input. So let's put the input up here. And now it's going to yell at me that we don't have any data. So we need some test data. In this case, we're going to do inline data. And this is going to be our input. Okay, that's not really what I wanted. Sure. So there's our input. Now if I save this, everything goes green again because, of course, we now took this from here. However, we still have some hard-coded numbers here, right? So let's do this instead. Let's have 2, 4, 6, 8. All right, so then we've also got int first start, first end, second start, second end. Okay, and we want to do first start, first end, second start, second end. And now we save and we run and we're back to green again. But what's interesting now is that this collapsed up a little bit because the name of this test has changed. Let me slide this out for just a second. So the name of this test has changed, and you can see the name of the test now reflects the data that's being put in there. And so what that's going to mean is when I add more data, we're going to see the name update for each row of data. So let's go get our second row of data now, right? So it's 2, 3, 4, 5. We're going to throw that up here. Inline data, 2, 3, 4, 5. So we expect 2, 3, 4, 5 here, right? So now if I save, we've got a failure for 2, 3, 4, 5 because instead of 3, we got 4. Well, that makes sense because remember, we hard-coded 2, 4, 6, 8 up here. So now our second set of data is going to cause us to actually give a reasonable implementation here of this. Okay, so let's do that. But what's cool here is that I can always just go rerun each one of these individually. Well, not in the live unit testing, but like if I go to the Test Explorer will show us these tests. And let me just slide that out there. So I could go rerun each of these individually without worrying about, the other ones. So now you can see that the red here is just kind of indicating that that previously ran because it got hollowed out, right? And so if I run the red one, now the green one will get hollowed out to say, yeah, you didn't run this currently, but the last time you ran it, it was okay. So, all right, let's go back to live unit testing because that's actually mostly what we care about today. So there's no way for me to hard code my way into this, right? I actually now have to start thinking about this. And the form of the data for the input is, let's see, begin, end, begin, end. Okay, so we know that that's the form of the data that we're interested in. And we have a couple ways that we can sort of approach this. We can start splitting the string apart, right? So if we were going to split the string apart, what would that look like? It would be first split on the minus, then for each piece, we would remove this and this. We would split on the comma and then parse the values. All right, so if we wrote that by hand, perfectly reasonable thing to do, that's essentially what it would be. So that's a decent chunk of code. We can use a regular expression instead, right? So the alternative would be to use a regular expression, which is I think what I did in when I did it live, and we'll do it here. So we'll do regex here, right? Regex is a new regex. And what this looks like is we have an opening parenthesis, we have one or more digits, we have a comma, we have one or more digits, we have a closed parenthesis, we have a dash, we have an open parenthesis, we have one or more digits, we have a comma, we have one or more digits, we have a closed parenthesis. And of course, we have to double all these up because that's like that, or we can do it like this, which I like a little bit better. So now we can see that this is here. Thanks to the regex coloring, we can also see what's going on here. We also need to do captures. So the reason we had to escape these is because this is normally how you capture values. And we actually want these values and we want to throw away everything else, right? So our regex is going to look like this and it's going to have captures. So what you do with a regex is you match it. So we're going to match the input, right? At the moment, we don't have anything that says this isn't going to succeed. So let's just go ahead and plow on through and pretend like it's always going to succeed. Okay. This then would be, we're going to return this. We're going to do an int parse on match groups, one value, and we're going to do an int parse match groups, two value. All right, and we're going to do the same thing down here, int parse match groups, three value. Groups 0, by the way, on a match is the whole string that was matched, the whole match, which would basically just give us the input string back. So then we have int parse match groups 4 value. Okay. Given that, now when I save, everything fails. That's interesting. That's actually not what I expected, but that's why we do TDD. So let's go save. Format exception. The input string blah was not in the correct format. Okay, the input string blah was not in the correct format. That is on line 18. So that's this. The match failed. Well, isn't that interesting? Oh, that's because I put parentheses here. There's not actually parentheses. I made a mistake here. Okay, that's fine. There's not actually parentheses there. So let me save this and let's see how we come out. We should have 2 successes now, I'm assuming. Except now we have I can't tell if it's running. There's so much stuff going on here. Test run completed. All right, input string, empty string is not in the correct format. So you're telling me that the input string is not in the correct format. I don't understand how that could be. Let's set a breakpoint. All right, so let's find out what's going on here. We'll go back to Test Explorer. We'll just debug one of these and see if we can figure out what's going on. Okay, so the input is 2-3, 4-5. Okay, well here's obviously I did the wrong thing here. I screwed up the commas and the minuses, right? So it's 2-3, 4-5. Now, I don't know why when it was running, it would say that the input string was in the wrong format and then give me an empty string. That's a weird error message, but whatever. Let's go back to live unit testing now, and you can see we've gone green. Okay, well, here we go. I mean, obviously, I screwed up the regex twice. So it's a good example of, how the TDD cycle is helping me a little bit. Great, we can take this breakpoint away. We can take all this text away. So for the moment, that's all good. This here that says 1 out of 2 passing, obviously this is from the Test Explorer and not from live unit testing, interestingly. So if I run them all in Test Explorer, I should see them all go green. I think I actually wanted to click run all there, not just run the one. And now we've got 2 of 2 passing. That is kind of interesting that live unit testing doesn't feed into this, but whatever, it is what it is. So I'm always one of these people who's kind of like, all right, we're in a green state now. Is there anything we can do to make the code better? Right, that's the refactoring process. And when I say refactoring, what I mean is a very specific thing, which is you're in a green state and you change the production code to stay in a green state. If you're touching the tests, you're not refactoring, you're doing something else. So is there anything I can do in the production code to improve it? I don't think so. Although, interestingly, we get a suggestion here to do a generated regex, which is apparently a performance optimization. So sure, let's see what that is. We're going to call this pair regex. And that's a private static partial regex, pair regex with a generated regex. So that'll just give me the regex. The reality is we don't actually need, right? We don't actually need that to be there, right? We can just do a static regex is pair regex, right? So we'll just take that there. I don't like having unnecessary words there. So that regex can go away. Must have accessibility modifiers as non-void return type. Okay. Whatever, even though private is what it is. Okay, so we're still green over here, right? Test run completed, no errors, build completed, discovering. Yeah, I can never really tell exactly what's going on over here. One of the reasons I don't use this all that much. All right, so there's our pair parser. So we did not change the tests. We got all this stuff over here. So we could obviously come through here and we could add the rest of these, right? There is some value in that, but also maybe not some value in that. We have already talked so far about error conditions, right? And I remember I said early on, Advent of Code generally doesn't give you errors unless they're going to tell you that there are potential error conditions. So when we look at our input data, the only place we would ever run into error conditions would be if we put bad data in there accidentally. So let's talk about, though, remember, we're trying to think about what would this be like in production? What are the error cases that we're interested in? We're using nullables. So like right now, let's see, we would say fact, public void, cannot parse null, right? So this would be like this. We would say, oh, you know what? Before we do that, I said I wanted to talk about arrange, act, and assert. So I like to write my tests in a format called arrange, act, and assert. So I put these comments here to let you know that that's exactly what was happening here. Although I don't normally put those comments in there, it's noise. So for me, I use sort of the blank line to sort of separate. Here's a range. A range means what are the things I need to do to get ready to test the thing I'm going to test. So in this case, I need to make a pair parser. And then we say act. This is almost always a one-liner, which is what is the action that I'm testing, right? So I'm testing the parsing of the system under test. And then assert. What do I need to do to verify that that these values are what I expected? Some people like to say I only like to have a single assert, and obviously we would have violated this rule for those people. We have 4 asserts. I agree with that, but I agree with it in a different way. I agree that what we want to test is one logical thing, and we may need multiple assertions to test that one logical thing. And so the logical thing that we're asserting here is that all of this data that we got back is correct. So one of the things we can do here is, by the way, we could deconstruct the values as they came out, which actually means we don't need result anymore, which is kind of nice. We can do that, right? We can also use var for all of this, right? So use an implicit type. So we can use implicit. And then once we have implicit types here, one of the other things we can do is, so they say you can put names here. You can convert this to a record, which is interesting. So instead of having this be a tuple, you could make a record out of it. A record is just like a class, except it's got some special rules about it, and they're really easy to declare. But what I was going to say is you could do this as well. If you're going to do var for both, you can just put the var out there. So there we go. We have this now, and I feel like that's perfectly reasonable. And I've explained arrange, act, insert. All right, so let's come back here to say cannot parse null, right? So let's grab our system under test. There's going to be, if I try and do system under test parse null, right? I expect that to throw something. So at the moment, it's already run this, and it's basically saying, hey, argument null exception value cannot be null input. That's interesting, but it didn't come from where you think it came from. It came from the regex match. It didn't come from us. The interesting question is, do we care about that? We have turned nullable on, I thought. I remembered us having nullable be on, so I'm kind of confused why it lets us pass null there. Kind of convert null literal to non-nullable reference type. Is that going to be a compiler error? It's just a warning. So if we want this to be a failure, CS8625, we need to do warnings as errors. So let's go turn that on, and I think that's warnings as errors, true. Okay, so now if I do that and we come back to live unit testing, what we're going to see is we should now have an error. We don't. Well, that's interesting. Okay, did I not do that right? Warnings as errors. Comma separated list of warning numbers to treat as errors. Okay. That's not what I expected, but okay. CS8625. 8625. There's probably like an all or a star that I could do, but now let's try and compile. There we go. So now we have an error. So that's better. Now we can't even pass this. So if we wanted to have this as a guard of sorts that this thing does is, hey, tell me that input is not valid. We could do that, right? We could basically say if input is null, right? We can say throw new argument null exception for input, right? So we could do that. We still can't pass this as null because with nullable turned on, we're not allowed to. So we can tell the C# compiler, all right, I know what I'm doing. pass null even though we're not allowed to, right? And now this test is failing with an argument null exception from the place that we sort of expect it. So how do we do that? We can get an exception out of this by recording exception from this line of code. And then we say not null, right? Assert is type argument null exception ex assert equal input ex. We need the argument exception out of this. Argument exception. Argument exceptions parameter name. So we can do that. And now we get a green test here when we do that. Do you need to write tests like this? You know, this is one of those things that people ask me. I tend to like to write guard clause tests because I tend to want to write guard clauses. And I don't want to write production code without tests. That said, I mean, this can be fairly verbose. Like if we had 6 or 7 parameters here, I might have to write 6 or 7 versions of this. You can do it a little quicker, except it sort of violates the range act assert pattern. So you can see I still have a range act and assert here, right? So there's an alternate way we can do this. So instead of doing this, what we'll do instead is we'll say assert throws, right? And we're going to say argument null exception, right? And then we're going to grab our line of code, put that right there. That will give us a passing test. And then one of the things you can do when the assert throws is called with something that derives from argument exceptions, you can also pass a first parameter, which is the parameter name, right? So the parameter name in the test code. So now we can do the parameter name test here. So we get this all in one line as a green test. So that's a little more compact. Let me arrange this a little bit better so you can see it on the screen, even though that's, you know, maybe a little bit excessive. Okay, so now we have this green. We've also noticed that we've got some greens and some reds that have been showing up here. All right, so if I do input 2, we get the greens and the reds showing up here. That tells me I probably actually don't need that to be open, so I'll give us a little bit more screen real estate here. You'll also notice that it's sort of tracking the lines of code that have caused failures, right? So the failure case is happening here. Every time we get down here, it's resulted in a passing test, which is nice. But here we have a failure, and that's because we're throwing it with an input, not input 2, right? So if I go back to input, then that'll go back to green. And now we're not, now it all fits on one line on the screen. So there we go, a little bit better. So that's one error case. So what are other error cases we could think of? We could think of error cases where we pass maybe an empty string, right? So we could do that, public void empty string throws, right? And this is an opportunity for us to think about exactly what we want the system under test to do in this case, right? So let's find out what it does now. And what it does now is, oh, interesting. I thought it would show me the results. Do I have to come up here to show the results? I guess I have to pop this open momentarily to see the results. But if I just pop it open momentarily, then I can make it much bigger anyway, which is probably better. So the input string was not in a correct format. So this is coming from the match. The int32 parse. Well, int32 parse is not where I expected that to throw, right? But we never checked to make sure that the match was good, right? So match success is the property that we would look at to tell whether we had success. So I think what we want here is we want an argument exception, right? We'd say assert throws argument exception for input against this, right? We can also grab that exception out of here as well, and we can do a full more asserts on it. We don't need a blank line there. Let's see. Well, maybe we want the message to say expected data in format of number dash number comma number dash number. Something like that, right? So that's going to be our exception message. So when we run this, obviously, this is not going to be the case. We didn't throw an argument exception. This is where we started to fail, right? So we're going to say if not match success. That's when we're going to throw new argument exception. And the version we want is the one that takes a message and a parameter name. So we want this expected data in format of this, name of input. Okay, so now when it runs these tests, we get a failure in a different place. That's kind of interesting. That's not actually what I expected. I expected it to tell us that we didn't correctly parse. Expected and actual. Expected data. Oh, right, parameter input. Because of course, argument exception, when you give it a name, also puts the extra stuff here to say what the parameter name was that failed, so that when you see the exception message, you see it. So instead of doing an equal, we're going to do starts with. Okay, so doing that now makes our test go green. That's just because of the way argument exception, when you pass a message and a parameter name, it puts the parameter name in the message for you, even though you didn't actually have the parameter name in the message to begin with. Okay. Again, people are going to ask, is this something you should test? And in particular, obviously, what happens in error conditions is something I generally want to test. This is the line that I think sometimes gets people a little bit confused, which is, do you actually care about the message? Some people say yes, some people say no. The reason why I suggest yes is so that the argument exception is being thrown from the right place. So here's an example. Let's say I were to just throw new argument exception. Hello. Right? Now, obviously, I wouldn't do this for real, and it's going to cause all of our tests up here to fail. But if I did not, for example, didn't have this line of code here, and for whatever reason, this code wasn't here, right? I get a different argument exception, right? Now I'm getting an argument exception that is failing because of the wrong message, because I got the wrong argument exception. It was the right type, right? If this line of code isn't here, this test is going to pass because it's the right type, but it has the wrong message, which means it's the wrong argument exception. So you kind of have to make that decision for yourself, whether or not you think that is something worth testing. Okay, so let's get ourselves back into our normal position. Is there anything else we care about? There's probably one more thing. There's a limit to the size of int. So int is 32-bit, which means 2 billion and change plus or minus. If these numbers were bigger than 2 billion in the format string, we would get failures from the int parse of an overflow, some kind, right? So that's a third one we could write. Not going to bother to write that, but that's another one we could write. Okay, so I think our pair parser is good to go. So now if I go back to the problem, I've got a bunch of data here. If we wanted to add a couple more, we could, but I think, from a data perspective, we're okay. Like the reality is I generally like to have at least 3 rows of data just to make sure that, something looks good. So I guess we'll put a third row of data up here just for fun, right? And that's going to be 5779, and then we save, and everybody's still green. Okay. And I'm going to start rolling some of these things up because they probably don't matter all that much. Okay, now what? The other thing now is we need to have, we need to do a contains test on ranges. So what we would like to do is understand whether one range is fully inside of another range. So let's go look at range, because what if range already has this feature? contains. Let's not do regex search. So range does not have contains. It has equals, right? As a toString, very nice. Start at, end at. So these are statics. Take a range and move it around. Get the offset and the length, sure. Okay, so it doesn't have anything it contains. So the next thing we want to do is we need to have something that does a contains. So this isn't a pair parser anymore, a pair parser problem anymore, right? So we're going to go ahead and actually start something else. And I'm going to use a feature of C# called extension methods. So what I'm going to make is I'm going to make range extensions, right? We're going to put range extensions over here because this is where our production code is. And then let's go make range extensions tests over here as well. So normally, by the way, we wouldn't put this all in one library. Normally you'd have production code in one library, tests in another library, but we're just trying to save time today. So let's go make the range extensions tests, and it's probably going to put that in the right place. Okay, good. So there we are. So how do extension classes work in C#? You make it static, right? And then what we're going to do is we're going to write a function that looks something like this. Now, I know this is not the TDD way of doing it, but I'm trying to explain the language function. So I'm going to write the skeleton of this function first so that you can see how this works. So we do range, and then a range other. Well, now let's throw new not implemented, and this also needs to be static, which is why it's red. Okay, so what does this mean? So this keyword is a little special keyword, and basically what it says is we're going to add a function to range called contains. So when I have a range and I hit dot, I'll be able to see contains as an extension method, and it will take whatever the other parameters are as its parameters. So in this case, I'll take an other side. So how's that going to look for us over here? Let's go take a look. So we're going to start out with a theory, right? So let's do an inline data of 2, 3, 4, 5, and false. Okay, so let's say public void, we'll just call this contains tests. These are kind of like the success case tests for contains, right? So it's going to take begin 1, begin 2, or sorry, end 1, begin 2, end 2, and expected results, right? So we expect that 2, 3 does not contain 4, 5. That's what I'm trying to get across here, right? So let's get our ranges out of this. So our range 1 is going to be a new range from begin 1 to end 1. Range 2 is going to be a new range from begin 2 to end 2, right? And then we need our system under test, which actually we don't because it's static, you don't new it up. All right, what we'll see here is the result is going to be range 1 dot contains. So you see now we have this as an extension method, and it's taking this one parameter of other, right? So does range 1 contain range 2, right? So all we want to do is, did we get the result that we expected? Okay. And so here, of course, we're going to get failures. Why do we get failures? For the simple reason that we have not implemented the method yet, right? So we haven't implemented this yet. So what's the easiest way to make this pass? Well, you already know that, right? Return false. Do that. Well, the test is going to pass. So we need to know really what is some more test data here that would be useful for us. And what we can do is we can actually take some of that test data from our problem, right? So these are cases that we knew were going to be contained. So we've got 2, 8, and 3, 7, right? So let's do that. Inline data 2, 8, 3, 7 is true. And actually, we should change this data to one of the pieces of data that we have up here. So 2, 4, 6, 8. Let's do that, right? 2, 4, 6, 8. So we know 2837 is true. And we also know 6646 is true. Well, actually, 4666 is true. But that's an interesting thing too, right? So 4666 is true. But the opposite is not true, so let's go ahead and put that in there as well. Inline data. 6646 is false. Okay, so what we have here now is 2 of these tests are passing and 2 of these tests are failing for all the wrong reasons, right? 2 are passing because we hard-coded. I mean, we could make the other 2 pass by just doing this. So what does it mean for one range to be contained inside of the other? That is fairly straightforward, right? If we look at the beginning part of the range, so we know 6.6 is contained inside of 4.6. We know 3.7 is contained inside of 2.8, right? If we look at the beginning of the range, right, 6, and we say, are you anywhere in this space? Yes, you are. So that means the left-hand side is inside the range, right? And then we look at the end, 6, are you anywhere in this range? Yes, you are. Okay, well, then you're contained in that range. So same thing here, right? 3 is somewhere in this range, yes. 7 is somewhere in this range, yes. But if we flip it around, like, so if we were to do the opposite, 4 is not inside the range of 6 to 6. So it obviously does not. So what does it mean to be inside the range? Pretty simply, it means you're greater than or equal to the beginning point and less than or equal to the end point, right? So in this case, 6 is both greater than or equal to 4 and less than or equal to 6. Similarly, 3 is greater than or equal to 2 and less than or equal to 8, right? And then the same thing on the other side. And that's really it. We just have the one set of comparisons there. So the way we make that work then, if we come back to our tests, is we would say return. So we want to know if the other is inside our range, right? So we're going to say other start is less than or equal to, or sorry, greater than or equal to range start, right? And other end is less than or equal to range end. Right, so that's pretty much it. And what are you upset about? Inclusive can't be index and index. Really? Really? Okay. These apparently have to be value. Well, this is kind of an interesting, like, I feel like range is a weird class in this case. Okay, so now all of our tests pass, which is good, right? Because we know that this range is inside of this range. We have both failure and success cases here. That's good. What are the error conditions that we haven't handled? Well, range is a struct, which means it can't ever be null. Unlike a class, right? Ranges can't ever be null. So I don't think that that we really have anything else to do. Like, I think this is just good enough. Okay. So what's left for us to be able to solve this and get an answer, right? So we need to count all of these. We need to count all of these as our input data. Count the number of times one is inside the range of the other. Okay, so we need our input data for starters. So there's our input data. How do we want to represent the input data? That's a good question. We could have a text file here that we just read. What we don't have yet is we don't have a way to just sort of run something and get a result because this is a unit test project. So let's just say, we'll just call this thing part 1 tests. Part 1, actually let's call it the part 1 solver. And we're going to solve it with a unit test, which is fine. And we'll do, let's see. What is the easiest way for us to do this? I hadn't really thought about this. I mean, we kind of need a console app here, I think. So maybe the part 1 solver here, it doesn't make sense. Let's do this. Let's make a new folder. We're going to call this a day 04 runner. Okay, inside the day 04 runner, where'd my terminal go? We still have our terminal. Let's see, terminal. Yeah, it's still there, right? Okay, so let's go. Yeah, you'll notice there's a little bit of painting weirdness with the browser. So I'm using this third-party browser thing, and you'll see that it always just kind of like hangs over the top of everything, which is not great. So let's go back into our terminal. We're gonna go to day 04. No, not day 04. We're gonna go to day 04 runner. So we're gonna do a .NET new console here. Output, it's O for output, right? Output here. So it's gonna make day 04 runner CS proj for us. Okay, that's great. We'll do a .NET SLN add day 04 runner. Actually, we made a new project. Yeah, that is kind of weird, isn't it? I kind of want to make a new project out of day 04 so that we can reference one from the other. So I'm going to convert this into a project. So I'm gonna break some stuff here. This is what happens when you don't plan. Let's go to day 04. We are going to .NET. Let's see. Let's yeah, .NET new XUnit here, right? And then .NET SLN add day 04. Yeah. Save everybody, that's fine. And then back here, we're gonna add the day 04 runner. Yeah, that's fine. And then we're gonna do .NET SLN remove. And you're asking me why I'm doing this in the command line. I'm just used to doing this on the command line. I think it's SLN remove, right? Yeah, SLN remove. Oh my goodness. Unit test, the live unit test runner is really upset with me. We're gonna remove this. Yep, okay. Everything's gonna go away for a little bit. So now we have a day 04 project with its own usings. We have a day 04 runner with a program. Let's go ahead and add a reference. Add a project reference to day 04. And yeah, there's no rhyme or reason as to why I do this, the way I'm doing it. It's really no rhyme or reason. Okay, live unit test runner now running day 04 unit test 1. Let's go ahead and build everybody. Let's see what happens here with the live unit test runner. Right, it's upset because I think, I mean, I don't know. Edit the playlist. Yeah, I think this live unit testing thing, I just never really makes sense to me. All right, let's get rid of it. All right, so we come over here with the unit test, with Test Explorer. Let's just go ahead and run everything. Let's see what it says. Okay, so we're back to having everything run, which is fine. It's just in its now in its own project. Now we're going to have the day 04 runner. And so what we want to do is we have test data. So let's grab our test data. All right, so if I come over here to program, right, we're going to have test data is going to be this. It's going to be a multi-line string. It looks like this, I guess, right? And then we're going to need to have a using for day 04. All right, so what does it look like when we're actually using this? Why do we not have, oh no, it's Advent 2022 day 04, there we go. So we have our pair parser and we get ranges out of it. So we're gonna do for each line in test data split on this, I guess, right? We're using character string line feed. Okay, so we'll do that. For each line in that, first of all, we're going to need a pair parser, right? So our parser is a new pair parser, right? And then we're going to parse the line, right? That's going to get us our result. It's going to tell us we can explode this with first and second, which is fine. That's what we'll do. We'll do first and second. And then we'll say we need to keep a running count, right? We need to know the number of times one was contained inside of there. So given our test data, we should get 2 out of this. So at the end, we're going to do console write line. Part 1 is count. Okay. Let's do contains. That's what we'll call it. We'll call it the contains count, right? So if first contains second, or second contains first, right? We're going to increment the contains count. So given this test data, let's see. We're going to run the day 4 runner. See what happens here. We get 2. Okay, that seems entirely reasonable. Now we know that with our real data 532 giant thing, this is a lot of fun, right? Let's just make test data. Let's see, add. Yeah, that's fine. Yeah, that's fine. Let's go get our real data, right? So here was our real data. It's gigantic. All right, 1,000 lines of stuff. And so what happens when we run this? We get 532. Okay, so we feel fairly confident that we have done the right thing for part 1. And we TDD'd our way into it, right? We made a pair parser. We used ranges, and we had an extension to the range class for contains. And then we're ready to go. So what is part 2? Part 2 is the same thing, except it is now testing for overlap instead of contains. So what does overlap means? Overlap means any number is in both sides. So here we have no overlap. Here we have no overlap. Here we have one bit of overlap. Here we have a bunch of overlap because contains is like overlap, except it's more severe, right? So obviously it contains is an overlap, and here we have overlap as well. So in this case, with this test data, 1, 2 non-overlapped, right? 1, 2, 3, 4 overlapped. So we should get 4 for part 2. Okay, so how do we TDD our way into this? Well, we're going to make another range extension, right? And so what we're going to do is we're going to use, let's use our data from here. So we know, let's use 2468 again, because that's not an overlap. We'll use 5779 as an overlap, and then we'll use one of these as an overlap as well, right? So let's just copy this test, and then we can say this is the overlap tests, right? So we know 2468 does not overlap. 2837 we know overlaps because it's also a contains, right? And then what's the third one we were going to do? We were going to do 5779 is an overlap. So let's do inline data 5779 true. So these are currently calling contains. What we want is overlaps. So we want a new function called overlaps. That's obviously not going to work because we don't have, right, our red state now is going to be the fact that we can't compile. So if we come back to range extensions, we're going to go ahead and write overlaps the exact same way we did before. Overlaps, this range, other. I'm going to throw new not implemented. All right, so let's get us into a running red state. So we go ahead and run. right? And now we can look at this, range extensions tests, right? We can just concentrate on overlaps. These are all failing because of the not implemented exception, which is what we'd expect. So overlap is kind of like contains, except it's a little bit different, right? So what does it mean to overlap? If we look at the data, right, we need to know if any of these numbers here are in any number here. So it is a very similar kind of a test. It's just a little bit different, right? So if this is the range and we want to find out if this one has overlap, right? So we look at 7. 7 has to be somewhere between 5 and 7, right? Or 9 has to be somewhere between 5 and 7. That's really what it is, because if we flip it around, all right, so if we say 5, is 5 anywhere between 7 and 9? It's not. But is 7 anywhere between 7 and 9? It is, right? So it's just like contains, but there's more checks. So what we want to do then for this is we want to say, does the other start value, I want to say, is the other start value greater than or equal to, let's see, yeah, greater than or equal to range start, and the other start value less than or equal to range end value. And you have to remember type value. Or is the other end value greater than or equal to range start value and other end value less than or equal to range end value. Okay, that's what we care about. So now if I do that and I go rerun our tests, they should all pass. My logic is correct. So there we go. So now we've got the overlap. Again, like contains, we've got success cases and we've got failure cases, right? We don't have any validation to be done here. I guess validation we could do is like, the ranges shouldn't be negative, although that even doesn't really matter, because these are very generalized utility functions. In fact, you could ask yourself, why don't these functions already exist? It'd be really convenient for us if they did, but we had to write them, so that's it. So now let's go back to our program, and what exactly is part 2 supposed to do? We're going to do now overlaps, right? And then we're going to do the exact same for each loop, right? Except we're going to do overlaps and overlaps. So if we use our old data, let's go grab our old data, put our old data up here, okay, and run it. We should get 4. We should get 2 and 4. We never printed anything out. And we incremented contains instead of overlaps. That's my bad. I'm going to move this console write line up here. And we'll do overlaps. All right, so we should get 2 and 4. The fact that we got 6 told me we probably got 2 and 4. All right, so there's 2 and 4. Let's go ahead and pull our big data back in, right? So we'll go ahead and put our big data back in here. Right, and we got 854, and if we scroll down here, 854 was the number we were expecting. So there we go. That is how we got our TDD'd our way into classes to solve day 4. And the difference between what I did here and what I did live on day 4 is obviously that first of all, my solution looks quite a bit different, right? Let's go take a look at the other my day 4 solution that is over here. So here's we're ready to go for day 7. All right, so if I look at my program, right, so you can see I did end up using a regex, same as we did elsewhere. I ended up using anonymous tuples, right, so I didn't use the range class at all. I used longs instead of ints. Yeah, that's fine, whatever. And I put the comparisons directly in here. And so you could see this if, else if, is pretty much exactly the same as what we saw here, which is if this or this, do this, right? So the two halves of the if or this. And that one comparison that we saw there, that looks like low less than low, high greater than high, right? That looks exactly like our range extension, low greater than low, high is less than high, right? And then again, this is twice as many comparisons over here, so we have 4 comparisons times 2, so it'd be 8 comparisons total. So when I come back over to the solution we had over here, we have 1, 2, 3, 4, 5, 6, 7, 8. And rather than using ORs, I did if else, if else, if else instead of the ORs, right? So that's really the difference. Is there anything wrong with this code? No, there's nothing particularly wrong with this code, but it's also not very illustrative of the problem that's trying to be solved, right? It's not obvious what this code is supposed to do. And left and right and low and high, those are fine names, but like, what exactly is this? Unless you can look at this code and say, oh, this is doing a contains test, you have to be able to read the code and understand that it's doing a contains test, and that's what it's counting, is the number of times things are contained inside of each other, right? Whereas if we go and look at the other code that we ended up with, right? First of all, the parsing is done with a parser, so it's very obvious what we're doing because we're using a pair parser to parse pairs, right? And then the other thing is we named these range functions contains and overlaps, so that when we actually use them, this code is now super readable. It's really obvious what part 1 and part 2 want us to do, which is parse each pair and count how many has one side contained inside the other side, or count how many has one side that overlaps the other side, right? So this code is much more readable, but it took us so much longer to get there. But that's because you should expect code that you're going to have to reuse and maintain to take time, right? It's going to take you time to write that code because the time you spend now is the time you're going to save when you're going to look for bugs, when you're going to try and understand what the code does 6 months from now. This is really kind of like, what is the value of that? And all of our tests that we wrote with TDD sort of helped us guide the design of the thing that was going to do all the work for us. And now we know that if we want to go change the pair parser or those extension methods, we have not only the documentation of how we originally thought they would be used, but it gives us a little bit of a backstop. If we want to go make changes to those things, we can go make changes to them without too much fear of breaking the things that we already know we're supposed to be able to do. And the more data that we can put into those tests, the more tests, the more complete we can make the test suite, the more confidence we can have in not breaking that code when we go and touch it later. So it's not uncommon for people to have more test code than production code because they're trying to be exhaustive about the things that they're testing to make sure that things are going to work in all the unexpected ways that data can get thrown at it, as well as the expected ways, right? So that's really it. That's all I want to talk about today. That's how you do day 4 with TDD. That's how I would do day 4 with TDD. If you want me to do this for any other days, throw a like on the video. Maybe throw a comment on there when a particular day comes around and you say, boy, this day seems like one that I'd really be interested in seeing done TDD style, and maybe I'll do that. So anyway, thanks for tuning in, and see you next time.